Hello, math students. Good to see you again. I'm back to teach you today the next lesson, which would be how to raise powers to a power, and also how we can change negative exponents to only positive and simplify without having negative exponents at all. So what I'm going to do is I'm going to go off screen here, and so you can see a little bit better. Um, my recommendation is that you write these down as I do them so that you have notes to go off of and so they can help you with the assignment, which is at the end of the slides today. So we're going to start with doing powers to a power. And you'll notice on my first example, I have 5 squared in parentheses and that whole quantity raised to a third power. What that really is meaning is that we've got 5 squared, which is 5 times 5, and we have that quantity written 3 times. And so what that means, there are 3 sections of that, 3 sections of 5 squared. You really end up multiplying 5 by itself then 2, 4, 6 times. So your final answer is 5 to the 6th power. That's what's really happening there. Now, the shortcut to that, if you notice that you have a base and a parenthesis here, 5 squared, and it's only separated, this guy's on the outside, what you're really doing is you're multiplying the exponents, okay? So you're going to keep that base of 5, and then 2 times 3 is 6, and that is what your final answer is going to be. Now, the same holds true for multiple bases inside the parentheses. Now, if you recall back when we learned about this year, every single number, every single variable does have an exponent on it, whether you can see it or not. So this 5 actually has a hidden 1 as an exponent on it. So the 4 is on the outside of the parentheses, and so that's the one we're really going to be multiplying by all the exponents on the inside. So we're going to first go back and multiply the 4 by the 1 to give us 5 to the 4th power, because 4 times 1 is 4. And then we're going to multiply 4 times 3, giving us x to the 12th power. And so that's what we have in our first step. Now, this part right here can be simplified further. 5 to the 4th power is really 5 times 5 times 5 times 5. And so we can simplify that to 625. And the x value, we don't know what that is, so we have to leave that one alone. So the final answer here is 625x to the 12th power. Now, do I expect you to know 5 to the 4th power in your head? Probably not. You can use a calculator to do that. You can either multiply 5 4 times, or in many calculators you use the little caret key, and that's what you get. 5 caret 4 would give you 625. Okay, that moves us on to example 3. And so this one looks different because it's separated here. Something I want to point out to you is that just because these are together, there's really a hidden time sign in there as well. There's a hidden time sign right here. So there's one missing exponent in here, and that's on this 3. There's a hidden 1 there. So we're going to do the same thing. We're going to distribute this 2 here to each of the exponents on the inside, starting with the first one. So 2 times 1 gives us 3 now to the 2 power, because 2 times 1 is 2. And then we're going to do the next one. 2 times 2 gives us x to the 4th power. And then I'm going to keep it separate for now. 2 times 3 gives us x to the 6th power. Now, this guy can be simplified in 2 ways. Just like before, 3 to the 2nd power, you can either do in your head or in your calculator. That is 9. 3 times 3 is 9. And now we have 2 bases that are the same. And in the last video that I did, you knew that if you have the same base, you can then add these exponents. So this now becomes x to the 10th, and this is going to be your final answer. And so that's as simple as that can go. And these top ones, it says use only positive exponents. We didn't run into any negatives that we had to deal with. Now, what happens if we do run into negative exponents? So let's get to that at the bottom of my page here. So if you have a negative exponent, all that means is that you're really dealing with a fraction. And so I want to do a little sidebar here. Um, so let's do a little example on this side. I should have done a number one to show you. So if I actually had 5 to the negative 2 power, that is not going to be a negative number. It's actually a very small number. So what that means is we're dealing with a decimal or a fraction. If you were to put that in a calculator, which I'll show you right now, okay, so 5 to the negative 2 power, it's 0.04, which is a very small number. Well, what that means is we need to make a fraction. And this part, the base with the negative, is going to go in the denominator, and we're going to get rid of that negative. And then on the top is anything positive. Well, you can't leave it blank. There's nothing else there. We make it a 1. So this is really 1 over 5 squared is 25. So 1 over 25 is exactly 0.04. And so that's how we're getting that. So with the variables, then we are going to do the same thing. If we have a negative exponent, the first thing we're going to do is we're going to make a fraction. We know we're talking about a fraction then. And so the base that has the negative is going to always sink to the denominator, and we're going to get rid of that negative. And anything else that doesn't have a negative exponent on it is going to go to the top. But if there is nothing else, you have to put a 1. You can't just leave it blank. This is the answer to this. Now, in example 5, we have more than one base now. We have a base of 5 and we have a base of x. Well, technically, just like above, there is a hidden 1 on this 5, and that's positive. So, because we have a negative 4, right away we're going to make a fraction. Well, 5 to the positive 1 is going to float to the top because it is positive. And x to the negative 4, just like before, is going to go to the bottom, and we get rid of the negative. And so technically that's the correct answer. You don't have to write a 1 on that 5 because it is understood. So either answer is correct here. If you're taking a test, probably this would be the answer you would see. And so it gets kind of wild and crazy with exponents. And they'll give you these long terms that have several different bases in there. So we have 5, an x to the negative 2, a y to the third, a z to the negative 3. And so if there's even one negative, right away we make a fraction. And then we just separate it. Everything positive goes to the top and everything negative goes to the bottom. So this is really a 5 to the 1 power. And so that's going to go to the top of our fraction. X to the negative 2 will sink to the bottom and we get rid of the negative. Y to the third is positive, so we're going to put that at the top. And z to the negative 3 is going to the bottom since it's negative, and we get rid of that negative. And then you can either leave your answer like that, nothing seems to cancel out here, or you can get rid of the 1 on the 5. Again, if you see that on a test somewhere, the 1 probably will not be listed. And so this is what the final answer would end up looking like. Last but not least, let's backtrack to the last video where we had fractions, and fractions mean division. They also mean that we're subtracting our exponents, if you remember from Monday. And so what we're going to do is we have the same base here, so we're going to get to subtract the exponents. You must always do the top exponent minus the bottom exponent. You cannot reverse order. So if I do that, I'm going to do 5 minus 8. So keep my base of x, but 5 minus 8, if you know your integers, or if you're using a calculator, you know that this is negative 3. So we get x to the negative 3. But the rule states no negative exponents or only positive exponents. So this now is something we have to take one step further. Since there's a negative exponent, we need to make a fraction. the negative then sinks to the bottom and becomes positive. Uh-oh, there's nothing left over, which means the numerator has to be a 1. And this is the final answer to that question. There's a middle step there on some of these. Okay, so that is our lesson for today. Hopefully, everything is clear to you. There's some practice on Khan Academy that we've listed for you on the next slide. Do the ones that you feel like you need to do. If you already feel comfortable, you can go to the final slide where there's an assignment on there, and much of this matches that assignment. If you have any questions, please, please, please email me, or if you have Mr. Caterino or Mr. Ricketson or Mr. Conway, email them. I hope you guys have a great day and hope everyone's staying safe, sane, and healthy. We'll see you soon.